carbon dioxide molecule, CO2?
The dipole moment is 0.
Very good. Why it is? Because carbon dioxide is a linear molecule. Carbon is the central atom, oxygen on either side, 2 oxygen atoms, and we know that oxygen is more electronegative. So the shared electron of this covalent bond will be more attracted towards oxygen side. So oxygen side will become a delta negative charge, fractional negative charge. The same way carbon side will get a fractional positive charge. This side also oxygen is more electronegative, so that will attract this shared electron more towards it. So this oxygen also will get the same fractional delta negative charge, and carbon the same way fractional positive charge. These two equal and opposite charges on either side will create two dipoles, but they are equal and opposite. The dipole moments are equal and opposite, cancel each other. So the total dipole moment of carbon dioxide molecule is 0. Dipole moment P is equal to 0. Carbon dioxide molecule as non-polar molecule. Non-polar molecule. A molecule in which there is no charge separation. Okay, there is no polarity, non-polar, no polarity. The center of the positive and negative charges will be coinciding. There is no charge separation. There is no permanent dipole moment. The dipole moment of such molecules will be 0. Molecules with a 0 dipole moment is called non-polar molecule. Got it? Can you give an example of polar molecule which is having permanent dipole moment?
Water.
Very good. H2O. If you take a water molecule, it is a covalent molecule. The bond formed between hydrogen and oxygen are covalent bond. In water molecule, we know that oxygen is more electronegative. So if you take the electron cloud picture of water molecule, you can see the electron cloud will be more towards oxygen atom because oxygen is more electronegative. So this area we can see more electron cloud density than hydrogen side. So the oxygen side will have a delta negative charge and hydrogen side will have a delta positive charge. So the water molecule will behave like a dipole. It is having a permanent dipole moment. So in water molecule, the center of positive charges and negative charges are not coinciding. The total center of the positive protons and the negative charges of the electron cloud are not coinciding each other. If the centers of positive and negative charges are not coinciding, such molecules are called polar molecule. So water is a polar molecule. Another example for polar molecule.
HCl?
Yeah, HCl is a polar molecule. If you take a HCl molecule, it is a covalent molecule in which hydrogen and chlorine are bonded by covalent bond by sharing of electrons. And also we know that chlorine is more electronegative, so the shared electron will be more attracted towards chlorine side. Since chlorine side will have more electron density, electron cloud density, so the chlorine side will get a delta negative charge and hydrogen will have a delta positive charge. So if you take a molecule of HCl, the centers of positive and negative charges are not coinciding, they are separated, and it is having a permanent dipole moment. Because of that, HCl is considered as a polar molecule. It has polarity. But if you take molecules of elements means like O2, N2, these are all covalent molecules, O2, N2, H2, Cl2. What will be the dipole moment of all these molecules of elements like O2, N2, H2, Cl2, etc. Oxygen molecule, between two oxygen atoms there are two covalent bonds, double bonded. In nitrogen there are three covalent bonds between two nitrogen atoms. You know the valency of nitrogen is, it is having atomic number 7, so the electronic configuration is 2, 5. 5 electrons are there in the outermost shell. It needs 3 more electrons. To get 3 more electrons, it will form 3 bonds with the other nitrogen atom. So there is a triple bond between two nitrogen atoms here. In oxygen there is a double bond. In hydrogen there is a single bond. Chlorine there is a single bond. And my question is, what is the dipole moment of all these molecules?
0.
0. Because if you take oxygen molecule, on both sides there are oxygen atoms. In oxygen molecule, two oxygen atoms are double bonded. O double bond O. So these two oxygen atoms are equally same electronegativity. Isn't it? Both of these atoms have same electronegativity, so they will attract electron on both sides equally. So that forces equal and opposite will cancel each other. Always molecules of elements cannot have dipole moment. Or we can say molecules of elements like N2, H2, Cl2, they will be always non-polar, no polarity, no separation of charges. Dipole moment will be 0. Polar molecules are possible if there are two different elements. In the molecule, carbon is there, oxygen, chlorine and hydrogen, okay, or hydrogen and oxygen in water, like in water. If there are two different elements with the two different electronegativity, then only polarity is possible. The molecules like O2, N2, they are non-polar. They are non-polar, they don't have polarity. In that molecules, the centers of positive and negative charges are same at the same point, they are coinciding each other. There is no charge separation, so they are called a non-polar molecule. But we can make them polar. That is our discussion today. We can make this non-polar molecule into polar molecule by inducing some polarity or polarization. See how it is possible. Suppose we have two metallic plates here. This is one metallic plate. Say it is positively charged. This is another one negatively charged. Means this plate I am giving, and suppose this potential is variable. This is variable. So this arrow sign shows that we can change the potential. We can increase or decrease the voltage. This side is positive. This is given positive charge. This side is negative. Suppose I am keeping a carbon dioxide molecule here. You know carbon dioxide is non-polar. Okay, this is a molecule of carbon dioxide. It is spherically symmetrical. In the beginning, it is spherically symmetrical, and you have to imagine this is CO2, carbon dioxide. It is non-polar, no polarity. It is suspended between two metal plates. One metal plate is positively charged, other metal plate is negatively charged. Okay. Inside the carbon dioxide molecule, there are negative charged electrons and there are positive charged protons. There is molecular orbital. You studied last year in chemistry molecular orbital theory and all. So there is molecular orbital, electrons are revolving in that. There are nuclei of carbon and oxygen. 3 nuclei are there, 2 oxygen and 1 carbon. But right now they are spherically symmetrical and the centers of positive and negative charges are coinciding now. Okay, they are coinciding each other. Now suppose I am giving a potential difference between the two plates and carbon dioxide molecule is in between. If I keep on increasing the potential difference, what will be the change happening for the shape of the molecule? Means it will elongate, correct? It will elongate.
Yeah.
The carbon dioxide molecule will elongate. When it elongates like this, molecules will get elongated. Okay. Out of the total particles inside the molecule, means positive charged protons are there, means nucleus is there, electron clouds are there. So can you tell me in which direction nuclei will be shifted, which direction electron cloud will be shifted?
Electron cloud will be shifted towards the left.
Electron cloud will be shifted towards the which plate you
Positively charged.
Okay. Electron clouds will be attracted by the positive plate, so it will be attracted this side. So electron cloud will be more shifted to this side. Nuclei positive charged part will be shifted towards negative plate. Got it?
Yes, sir.
Now there is a charge separation, and because of this
Yes.
charge separation, there is a distance between the two equal and opposite charges. Now this molecule has dipole moment, and we can call it is a polar molecule. This dipole moment is called induced dipole moment. Okay, this dipole moment is called induced dipole moment, and if I keep on increasing the voltage, potential difference between the positive plate and negative plate, sigma by epsilon naught is the electric field intensity between equal and opposite charged plates. If I keep on increasing the electric field intensity, what will happen to the dipole moment developed here? The molecules will get more and more elongated. So dipole moment also will increase. Okay. Now we are going to define a new quantity that is called polarization. That is what the heading written today. Polarization and dielectric breakdown. Polarization, it is represented by the letter small p. It is a vector quantity. It's a vector quantity. Now listen here. Polarization is the dipole moment developed per unit volume of a specimen of a dielectric. Now you come to this diagram, see this diagram. Suppose this is a capacitor, this plate is given positive charge and this plate is given negative charge. Explain here with the one molecule of CO2. The same thing we are going to explain here with a dielectric slab. This is dielectric slab. Okay, these are two plates of capacitor, positive plate and negative plate, and in between that one dielectric material is placed. This is a slab of dielectric material. It has lot of molecules, okay, large number of molecules. Now when we apply electric field like this, because of the positive and negative charge on the plate of the capacitor, all molecules will get elongated and all of them will have electron clouds towards the positive plate, and nuclei will be attracted towards the negative plate, unlike charges attracts. So we can see here in the positive end there will be electron cloud, and here positive, this is negative. So like this molecules will get elongated and all the molecules will have a dipole moment, and this side will be positive nuclei. So induced dipole moments are developed inside the dielectric slab. Induced dipole moment. What is the total dipole moment developed per unit volume of this one? Per unit volume, if you take unit volume of this dielectric material, unit volume of the material, inside the unit volume, how much dipole moment is developed? That is called what? Polarization. It is a new physical quantity. It's polarization. That polarization P is a letter small p is used for polarization. It's a vector quantity. This polarization, if I keep on increasing the electric field intensity, suppose I am increasing the positive and negative charge on the plate, we know that this molecule will get more and more elongated, or we can say this polarization is directly proportional to the electric field intensity for a isotropic dielectric medium. What is isotropic dielectric?
It's identical in all directions.
Yeah, it's in all direction, all part of the material, the same property for the molecules. Okay, the same property throughout. Isotropic dielectric slab. The polarization is directly proportional to electric field intensity. It means the dipole moment developed per unit volume increases with the increase in electric field. Polarization P is equal to a constant psi E. It is called electrical susceptibility. Electrical susceptibility into E. This electrical susceptibility, psi E, it is a constant for a given dielectric slab. Psi is a constant for a given dielectric slab. It is the ease with which a material can be polarized. If the psi value is very high for a dielectric material, means it can be easily polarized. By giving a small electric field itself, it can be easily polarized. Because the equation from that we can write psi E, electrical susceptibility psi E is equal to
P by E.
Yeah, P by E. What is P?
Polarization.
Psi E is the polarization developed per unit volume for unit applied electric field, correct? 1 Newton per Coulomb applied electric field. If psi value high means for a small electric field applied, we can get large value of polarization. It means such molecules are very delicate, very delicate. By applying a small electric field itself, you can elongate them. You can elongate them and they will get polarized. If psi value very less means they are very rigid molecule, it is difficult to polarize. You have to apply a large strong electric field, then only they can be polarized, then only the molecules will get elongated. What is SI unit of P? Polarization. You remember dipole moment capital P is equal to Q into 2A. One of the charge into distance between the two charges. Q into 2A. 2A is the distance separation between the two charges. Or dipole length. Q is Coulomb, distance is meter, into meter, Coulomb meter. Okay, polarization SI unit we can obtain. It is dipole moment, that is Coulomb meter, developed per unit volume. Unit volume. What is volume? Per unit volume. So volume is at the denominator.
Meter cube.
Now what will happen? 1 meter will get cancelled. So it becomes square here. Then what will be the SI unit of polarization?
Cm to the power minus 2.
Coulomb meter raised to minus 2, not down. Coulomb meter raised to minus 2 is the SI unit of polarization. And what will be the SI unit of psi? That is electrical susceptibility. You have the unit of polarization. What is that? Coulomb meter raised to minus 2. divided by electric field. What is electric field SI unit?
Newton per coulomb.
Yeah, Newton per coulomb. So this coulomb will get cancelled, isn't it? Sorry, Newton per coulomb. So this coulomb also will go to numerator. This per coulomb will go to numerator as coulomb raised to +1. So we can write coulomb square electrical susceptibility unit is coulomb square Newton raised to -1 meter raised to -2, or coulomb square per Newton per meter square. For susceptibility, one more SI unit is possible. Can you tell me that? We have the equation electric field is negative of the potential gradient dV by dx. dV by dx, if you take electric field intensity, this equation, difference in potential by distance is called potential gradient. Potential difference is volt, distance is meter, volt per meter. Electric field has two units. We have already Newton per coulomb and also volt per meter. Both are electric field. Remember that. Electric field can be volt per meter also. Then when we apply volt per meter in this equation, we will get another unit for psi. Polarization unit coulomb meter raised to -2 divided by electric field intensity is volt per meter. Volt meter raised to -1, volt per meter. Meter raised to -1 and meter raised to -2 will cancel, and here become meter raised to -1. Okay, volt will go to numerator. So we have a new unit, another unit for electrical susceptibility, that is coulomb, volt raised to -1, coulomb per volt, and meter raised to -1 per meter. This is another unit of susceptibility. So remember all these units, note down in your notebook. Before going to the explanation of dielectric breakdown, we will see what will be the effect. What happened here?
It's elongated.
There is a capacitor between the space, the distance between the two capacitor, or the gap between the two capacitor. A dielectric slab is introduced. It was a non-polar material, and due to the electric field, the dielectric slab is polarized, isn't it?
Yes,
And
sir.
if P is the polarization, that is the dipole moment developed per unit volume is P. Now, what we are going to explain is more important. That is, what is the effect of this polarization in the capacitance of this capacitor? Capacitance of this capacitor. See here, before introducing the dielectric slab, suppose the capacitance I am taking C0, Q by
V.
V. V I am taking V0. V0 is the potential difference between the two plates of the capacitor. And we know the equation for electric field intensity, the numerical value can be taken as E0. If E0 is the electric field intensity without dielectric, okay, without applying dielectric, in the air gap between the two plates, there is an electric field here from positive plate to negative plate, that is E0. It is given by the equation electric field intensity is equal to negative of the potential gradient if d is the distance between the two plates of the capacitor. If d is the distance between the two plates of the capacitor, then E0 we can write V0 by d. So what is V0 is equal to? What is potential between the two plates without dielectric? V0 is the potential difference between the two plates of the capacitor without dielectric. That is equal to what? E0 into. Now tell me, what is the equation for capacitance of the capacitor with air between the plates without dielectric medium? That is C0 is equal to total charge
Q by E0 by D.
Yeah, Q by E0 into D. This is equation number 1. Okay. Now come back to this capacitor. Suppose the dielectric is introduced between the two plates, and because of that, what happens? Molecules get elongated. The molecules are elongated, and at the positive end of the positive plate, we can see negative electron clouds are shifted towards the negative plate of the capacitor. Nuclei, positive nuclei are shifted. Now, if you take the entire specimen of the dielectric material, the complete bulk of the dielectric material, you can see inside the material. You can see inside the material here, positive and negative charges are coming near. Okay, positive, negative charges are coming closer. Positive one molecule is in close contact with the negative of the other molecule, so they will get cancel each other.
Yes, sir.
If you take the inside the bulk of the dielectric material, throughout you can see plus of one molecule and negative of the other molecule. Means electron cloud of one molecule and nuclei of the other molecule. They are close to each other, they will cancel each other. Charges will cancel each other. At the two extreme ends of the dielectric, you can
The
see
negative and positive remain.
yeah, at this end there is a net negative charges remaining which are not cancelled, and at this end a net positive charges are remaining which are not cancelled, and due to this positive and negative charges at the two extreme ends of the dielectric slab, that will create a new electric field. That electric field will be called induced electric field, and that electric field, induced electric field, what is the direction? Direction is from positive to negative, this way. So this induced electric field developed inside the dielectric material, that is written as EI, that is opposite to the external applied electric field. External electric field due to the charges on the plate of the capacitor is from positive plate to negative plate, that is in the figure it is from left to right, and the induced electric field developed inside the specimen, inside the dielectric slab, is opposite direction, right to left, because on the dielectric slab positive charges are accumulated at the end of the negative plate and negative charges are accumulated at the end of the positive plate. So electric field induced is opposite to the direction of applied electric field. Electric field is a vector quantity. Now there are two electric fields, one towards from left to right, that is applied one, other is induced from right to left. They are not equal. They are not equal. Depends upon the polarization ability of the specimen of the slab. EI depends. EI depends on the specimen, the dielectric slab. Different dielectric slab will have different EI value. So E0 and EI are not equal and opposite. E0 will be always high. EI will be less. Okay. So the net electric field between the two plates of the capacitor, what will be that value? If E is the net electric field between the two plates of the capacitor, E is equal to what?
E0 minus EI.
Very good. It is the difference of the two, that is applied electric field E0 minus induced electric field due to the polarization of the dielectric slab. So E is less than E0, correct? This new electric field, the net electric field is less than E0. Then what will be the new capacitance value? Tell me, equation for new capacitance, C is equal to Q by
E into D.
E into D. In this equation number 1 and 2, which capacitance is more, C or C0? C is greater than C0. Why? Because E is less than E0. E is less than E0. The net electric field decreases according to the equation E0 minus EI. So E0 is greater, so C0 will be less. C0 is the capacitance with the air in between, and C is the capacitance with the dielectric in between the two plates of the capacitor. Here C is greater than C0, means capacitance with the dielectric is more than capacitance without dielectric, because of which phenomena?
Polarized.
Due to polarization. When a dielectric slab is introduced between the plates of a capacitor, the dielectric material gets polarized, and due to the induced polarization, an electric field will develop inside the dielectric slab, and that induced electric field EI is opposite to the electric field due to the charges on the plate of the capacitor, that is E0, and the net electric field will be E0 minus EI, means the net electric field in between the plates of the capacitor decrease. When net electric field decrease, potential will decrease. When potential decrease, capacitance will increase. So the new capacitance C is equal to Q by E into D, that is greater than C0 equal to Q divided by E0 into D, because E is less than E0. Single molecule carbon dioxide molecule is placed between the two plates of the capacitor, and the charges on the plate I am keep on increasing, or electric field intensity between the plate I am keep on increasing. Okay, so what will happen? What will happen to the molecule if I keep on increasing the voltage? Suppose I am increasing the voltage to more than 1000, 10,000, 20,000 volt, very high volt.
Split.
Yeah, very good. That is what is called dielectric breakdown. When we keep on increasing the voltage, molecules will get more and more elongated. Molecules will get more and more elongated, and at one particular electric field intensity, at one particular strength of electric field intensity, the molecule will break into two. Okay, nuclei will go to one side, electron cloud will go to another side, and during the splitting of molecules, some energy will be released in the form of light and heat. That is what we are seeing, the lightning spark in the sky during thunderstorm.
Yes, sir.
So if there is a cloud, here, suppose in the cloud there are a lot of positive charges are there, and due to that positive charges, the air molecules, the electron clouds will be more attracted towards this side. Positive charges, electron cloud will be attracted, and molecules will get elongated. At one point, when the charges accumulated in the cloud become very high, when the electric field intensity become thousands of volt, in clouds, thousands of kilovolt is generated, thousands of kilovolt potential is developed. Because of that, what happens? The air molecules will break, dielectric breakdown. In this region, it will create a space with negative and positive charges, free negative and positive charges. It means air become conductor, and through that conducting area, electricity will start flowing towards the earth. So finally, the electricity will flow to the earth to neutralize it. So the complete charges will be cancelled by the flow of electricity towards the earth. So to flow the electricity from the cloud to the earth, there is no wire connection. If you are afraid of lightning, you can do one thing. You take a copper wire, connect one end to the cloud and other end to the earth, then there will be no lightning. You got the point?
Yes, sir.
If you are too much afraid of lightning and thunder, you take a long copper wire, one end you connect to the cloud and other end to the earth, but you should not touch, you will get severe electric shock. Then there will be no lightning at all. There is no problem of lightning. The charges from the cloud will flow to the earth and it will neutralize earthing. But since there are no conductors possible like that, and air itself will become conductor by dielectric breakdown. Got the point? Due to the high electric field intensity created here, the air molecules will get elongated and they will break into two positive nucleus and electrons, and it will create a conducting charged area. Through that conducting path, that is the lightning spark we are seeing, through that spark, through that lightning conducting path, electricity will start flowing towards the earth. And during that time, if you are standing here, and suppose you are in a plain football ground, you are the tallest one, when the electricity reaches near to you, always electricity seeks low resistance path. Always electricity seeks low resistance path. So if you are standing in a ground and you are the tallest one in that area, so it is easy for the electricity to flow through your body than through the air by breaking down and creating charges and passing. It is very difficult process. But if you are standing there, electricity can easily come through your head and go through your legs. So you will get electric shock. Got the point?
Yes, sir.
Suppose you are in a ground or in an open space, and during that time there is very heavy lightning and thunder. To escape from the electric shock, what you have to do? If you are in an open area, suppose you are in a ground.
Lie on the ground.
Yeah, you lie on the ground, so you will be safe. Because when you are standing, you are the tallest one, so easily electricity will come to your head, to your body, and will be conducted through your body. So if you are in an open space, if there is strong lightning and thunder, to escape from that, you have to lie down. Okay? And don't take shelter below long trees, buildings and all. Because long trees will become conductor, that time you will get electric shock easily. Okay? It is better to remain at the middle of your room, lying on the ground, that is better. And if there is a car in your home, get inside the car. I told you before, electrostatic shielding. Electrostatic shielding, you can be inside the car, you will be protected. Okay, I am here. This video was recorded yesterday from the school lab. We have a device called Van de Graaff generator. In Van de Graaff generator, actually it consists of two metallic spheres. One large metallic sphere is there that you can see here. This is the large metallic sphere. Inside that there is small one. Another small one is there. And always there is a belt rotating inside. Okay, a belt is moving like this. On this belt there is a comb, metallic comb here. From the metallic comb, continuously electron will be sprayed to the belt by corona discharge. By corona discharge, electrons will be sprayed to the belt, and the belt is continuously moving like this. So the charges on the belt will be carried to the smaller sphere, smaller metallic sphere, and the smaller metallic sphere and larger metallic sphere are connected, internally connected, and as per the equation we can see always the potential of the smaller sphere will be always high. Okay, the total charge, if you consider the total charge on the two metallic spheres, and the radius of the sphere, always smaller sphere will have high potential and larger sphere will be having less potential. Irrespective of the charge on the two sphere, always smaller will be having high potential, larger will be low potential. So this belt is continuously working and the negative charges are sprayed from the comb to the belt, and that negative charges are carried to the smaller sphere, and smaller sphere will get more and more electrons, more and more charges. But smaller sphere is always at high potential, and larger sphere is low potential. Because of that, electrons will be moved from smaller sphere to larger sphere. So the larger sphere will get more charges will get accumulated, and even if the charges on the larger sphere is very high, potential of smaller sphere will be high. That is coming in theory. I'm not going to explain that part. Okay, it is a derivation equation is there for that. So always inside the smaller sphere will be high potential. So electron will be continuously shifted towards the larger sphere. So the charges on the larger sphere will start accumulating to large value, and even it can create voltage about 10,000. Due to the high charges accumulated on the larger sphere, it can produce voltage about 10,000 volt, and due to that 10,000 voltage, we can produce dielectric breakdown in the air gap between. If I keep my hand near to the larger sphere, it will create a dielectric breakdown and I will get a severe electric shock.
Hi students, this is Venn diagram generator. It can induce very high voltage, about 10,000 voltage on this metallic sphere. When I switch on, you can see the working here. There is a belt rotating, and that will transfer the electric charges to the larger sphere. I am getting the electric shock. To see it's working, first about 1 second. Because of the repulsion, you can see the dancing balls inside. Okay, another experiment that is repelling because of the same charges induced on the heads. This is the dielectric breakdown of the air, and the spark is formed between the two balls. Just like lightning happening between these two metallic poles, because of the high charge induced on the large sphere, about 10,000 volts.
Okay.